All right, we are interpreting linear models again. Like I said earlier, probably said this in class a couple of times too. Most of the ones we've done in the past, most of the graphs are just arbitrary y equals something x plus something and all that. When we're doing linear models, what you've got to learn is that these linear models actually represent real situations in a lot of cases. So this is one that's doing that. We're talking about Grace. She sells insurance. She earns a base salary and commission on each new insurance policy she sells. The graph shows her income, I, plotted against the number of new policies, N, that she sells. So the relationship between I and N is linear. So what we've got basically is instead of y equals mx plus c, we're actually having I equals mn plus c. We are still going to find the gradient. We are still going to find the y-intercept, and that's how we're going to work out what the equation is, because that is actually going to be question D. All right, but I just want you to get in the habit of not worrying about it being a y and an x. We've still got our gradient, we've still got our intercept, so it is still in the gradient intercept form. All we've done is change the pronumerals, because I for income and N for number of policies. So there we go. All right, let's start with question 8. What is her base salary? So what you're looking for here is when she doesn't sell anything, what is her salary? We can find that when her sales are 0, it is $400. Next question, what is her salary in a week where she sells 8 new policies? Go across to 8, go up to the line, and come across to find out what her pay is. So $800 in that case. Next one says, how many policies does Grace need to sell to earn $700 in a week? So what we're going to do this one is we're going to go up to 700, and we're going to read across. We're going to be accurate as accurate as we can, and it looks as though it's probably 6 policies. So that's good. So we're just doing the same as we did in the previous question with the Australian and New Zealand dollars, but we're just using the graph to read off the answers. Next one, find the equation of the straight line. All right, well, here we go. We've already found what the y-intercept is because that was there. So we know in our case, the y-intercept is going to be 400. I don't really need a dollar sign. I'm just going to put 400. So what we've got to find is the gradient. Now the gradient is just the rise over the run. So pick 2 points. Doesn't matter which two. I'm going to choose that one and that one. Why didn't I choose this one? Because it's not in a nice spot. I want one that's on a corner there. That makes it a lot easier. So we're going to choose those spots. There we go. So what is my rise? Well, how much have I gone up? I've gone up $200. So my rise is 200. And what is my run? Well, I've gone across those 2 spaces, but I've gone from 0 to 4. So my run is 4. It's not 2 because my number of new policies, I've gone from 0 to 4. So my run has been 4. I will now simplify that and it will give me 50. So that is my gradient. I've now got my M and I've got my y-intercept, so I can write down my equation. I'm not going to do it as y equals mx plus c because I've got actual pronumerals I can use. So I've got I equals 50, because that's what we got for our gradient down there, N, because that's the number of new policies, and then plus 400. And that literally says she gets $400 base salary plus $50 every time she sells a new policy. So now I can use this equation to calculate the weekly income when Grace sells 3 new policies. So we're not looking at it on the graph. We're going to do it down here. We're going to go I. So we're going to do it when N equals 3. So I've got I equals 50 times 3 plus 400. That will give me 150 plus 400, which would give me $550. So that's how much she would earn. That's question E. And therefore, how much does Grace earn for each new policy? We've actually already worked that out when we worked out our gradient. Every new policy, she gets $50. Okay. That was a good one. We're done.